Okay guys, so this is for AMI Day 7. This video is probably going to be a little longer than some of the other ones were, just so we're perfectly clear on what we're looking at here. So it gives us, this is our Taylor series, and it tells you already that it converges. When it converges, you end up with x minus 1 is less than r, and you should have x minus 1 because it's centered at x equals 1. So what we're trying to do in part A is find what r is, meaning we need to find the radius of convergence. So anytime they ask you about doing radius of convergence or interval of convergence, that means you're going to do the ratio test. So with the ratio test, we do the limit as n approaches infinity. So remember, since this is in absolute values, this part doesn't really matter. This is really the only part that we're going to be concerned with. And I would probably rewrite this as 2 to the n times x minus 1 to the n all over n, just to make ratio test a little easier. So with the ratio test, first thing we do is plug in n plus 1. So 2 to the n plus 1 times x minus 1 to the n plus 1 over n plus 1 times, then we multiply by the reciprocal, so that's n over 2 to the n times x minus 1 to the n. So then we start looking for how things are going to simplify. So this right here doesn't technically cancel, but it's balanced, and since it's balanced, that means the limit is equal to 1, so it's going to look like it's going to cancel. Then for this next part of it, when we look at the 2's, there's 2 to the n plus 1 on top and 2 to the n on bottom, so the n's are going to cancel and just leave you with 1, 2 on the top. The same thing is going to happen right here with the x minus 1's to the n plus 1 and then the n. These are going to cancel and just leave you with 1 in the top. So when we've got everything done here, there's not actually any n's left. The only thing we've got left is 2 times x minus 1. And for the ratio test to converge, we need that to be less than 1. So the issue now is we want it to just be x minus 1 on the inside. So we're going to take everything and divide it by 2. So that's going to give us absolute value of x minus 1 is less than 1/2, which is what we were trying to solve for in part A. So that's all of our part A. Part B says we want to find the first 3 non-zero terms and the general term for f prime. There's really 2 different ways you could do this. Probably the easier way to do it is to think through what would the first 3 non-zero terms be for f. Once you know the first 3 non-zero terms for f, you can take the derivative and that'll give you f prime. So it says down here, if we look real close, we're starting at n equals 1. So let me get rid of some of this that I have written here. We're starting at n equals 1, so that means the first thing we're going to plug in is 1. So everywhere we see an n, we plug in 1. So that means it's going to be negative 1 to the 1 plus 1, so 2, so it's going to be positive. So you're going to have 2 to the 1, so 2 over 1 times x minus 1 to the 1. So that is your first term. For the second term, we're going to plug in 2. So when we plug in 2, that is actually going to make that negative. So 2 squared is 4. Over 2 is just going to give us 2. And then we're going to have x minus 1 squared. Now we are going to plug in 3. So 2 cubed is 8. Over 3 doesn't simplify. X minus 1 cubed. So that is the first 3 non-zero terms for f. We want the first 3 non-zero terms for f prime. So that just means we're going to take the derivative of all of these. So just think of this as being like a 2x, and the derivative of 2x is just 2. For the next one, we do power rule, so minus 4. We keep the inside. That's now to the first power. The derivative of the inside is 1, so we're good there. The next one, we bring down the 3, keep the inside. The new power is 2. Same thing, the derivative of the inside is 1. So that's our first three non-zero terms. We still need to do the general term. So if you refer to this, that will help you in figuring out what the general term needs to be for B. So it still alternates. So we're still going to have that -1 to the n plus 1. But it looks like all that happened here was we just brought each power down. So if we took this power and brought it down, it's going to end up canceling. So we're really just going to have 2 to the n, and then x minus 1, when we take a derivative, we subtract 1 from the power. And if we want to verify that works, if we started at 1, it does come out positive. We do have a 2, and the power is 0, so there is no x. If we plug in 2, it is negative. 2 squared is 4. 2 minus 1 gives us the power of 1, so it does seem like it checks out. So that is our part B. Now part C is the one that's kind of the least fun out of all of these. So for part C, it says it converges and it is a geometric series. So with a geometric series, remember a geometric series looks like some number a times some r to the n. So meaning we are multiplying by the same thing each time. So when we're trying to look at this, what we know that it starts with is a 2. So we're going to say our a is a 2. And then we want to find the common ratio. So each time it looks like it's multiplied by a -2 and then an x minus 1. So those are the things that we need to know for finding what it converges to. So with a geometric series, when it converges, our formula is a sub I over 1 minus r. So a is 2 over 1 minus r gives us that. So that is the function that it converges to, but we're going to go ahead and simplify that down a little bit. So we'll get 2, we'll distribute the 2, so 2x minus 1. So that's the function that it converges to. And this is what f prime converges to. We need to use that to determine what f converges to. So if this is f prime, to find f, we are going to integrate that. Okay, so the issue is going to be we need an initial condition because when we integrate this, we're going to have a plus c at the end. So the only thing we know for sure is that this thing is centered at 1. So if we think about, again, let me get rid of some of the stuff I've got here. If we think about if we took x equals 1 and plugged it into this, that would give us 1 minus 1, which would be 0, and 0 times anything is 0. So that means our initial condition is when x equals 1, your y value is 0. So we're going to need to use that when we integrate it. So then our issue here is now we need to take the antiderivative of this. So if we did u substitution, that's 2x minus 1, du is 2. We have everything we need. So that would be 1 over u du. So f is going to be ln, absolute value of u is 2x minus 1, then plus c. So now we need to solve for what c is. We know that this is our initial condition. So y is 0 when x is 1. And ln of 1 is 0, so that means c is equal to 0. So our function f should converge to ln of absolute value of 2x minus 1. So that should be what our answer is for that. If you guys have any questions, please let me know. But otherwise, I'll see you tomorrow with the next video.